Let's take a look at some of the cutters that a shaper uses. If you're comfortable grinding lathe tools, then a shaper should present no challenges to you. Now, this is not an instructional course on grinding. We'll run a different book and video for that later. But I want to show you some of the geometries of different types of shaper cutters. Now, of course, there's an enormous number of shaper cutters out there, and we're just going to show you some of the basics. The first, and probably your primary tool, is this. It's a basic roughing tool and maybe a light finishing tool. As you can see, it has a front clearance. It's generally about 3 degrees on a shaper. It has side clearance of about 3 degrees on each of the 2 sides. And then this, which is the primary cutting edge, of course has rake going away from it, as well as coming back from the tip. So this is made to cut in this direction across a workpiece, and it is an excellent tool for roughing out a workpiece and maybe used for finishing it with a slower feed. Now, if you're cutting angles, corners like a V-block or dovetails, you may need a sharper corner. This is essentially the same tool, only with a sharper tip. It again has front relief, side relief, and back and side rake. This tool can reach into corners. Now, the angle of this tool determines the smallest angle that it can cut. If you need to cut a smaller angle, then you need a specially ground tool, such as this one, which might be used for cutting a 60-degree dovetail. This tool is the same. The top and back rake on this tool are a little bit less, perhaps 3 degrees versus the 8 degrees or so on the previous tool. These angles are not particularly critical, although for maximum production speed you might want to go with the optimum angles. We'll list the optimum angles in the book, but in general for home use or hobby use, you'll just grind these such that relief and rake exist. Occasionally you will wish to cut vertically on the shaper, and for that reason a pair of these tools, this is a right-hand side vertical shaping tool, and you can imagine a mirror image of it for cutting down the left-hand side. So this tool is made to cut vertically down a workpiece, held approximately as I'm holding it now. And it has a slight back rake, basically the radius of the wheel on which it was ground, as well as some front clearance and a little bit of radius on the corners so that they don't leave sharp edges between indexing. Another common type of tool that you'll find on the shaper or for use with the shaper is this. It's a slotting tool, or if you're more familiar with a lathe, you might call this a parting tool. It has side clearance on both sides of the blade, it has front clearance, and then it has a back rake. There's no side rake to it, but there is a back rake. And this is excellent for slotting if you want to do any key seating or anything like that. It's also excellent for roughing out certain forms in the shaper. Another excellent roughing tool is this. It's a 60-degree angle with a radius nose, no side rake, and a significant back rake. Now, the significant back rake would be for steel or for aluminum. We might reduce that if we were cutting brass or cast iron, but this is an excellent roughing tool, particularly where you're roughing out something that has an angle on the side, such as a V-slot. Now, we've talked about the various roughing tools. Let's talk about a couple of finishing tools, tools to leave an excellent surface. If there's one thing that a shaper is renowned for, it's being able to leave an excellent surface on a workpiece. And by excellent, I mean far exceeding that which you're probably capable of on a milling machine. This is a general steel finishing tool. The cutting edge is at an angle of 25 degrees to the angle of thrust. It has no back rake on the the primary surface, but a great deal of positive rake because of the chip breaker that's ground in along the front of it. The back is also relieved, and there's a slight angle from the bottom to the rear so that the rear of the cutting tool does not drag on the work as it works forward. As this tool pushes forward, it'll cut a very small and light chip which is pushed off to the side. A tool like this is made for taking a cut of 1 to 3/1000ths depth of cut. Now that tool's for steel. For cast iron and for brass, a broad, flat tool with a very slight back rake can be used. A tool like this can be used with a very large feed horizontally, such that the work can be finished in a very few strokes because of the breadth of the tool. The breadth of the tool is basically flat. The corners are rounded to avoid leaving big gouges in the work between steps, and this leaves the characteristic pattern that a shaper or a planing machine would leave on the work, but also imparts a very desirable finish, and one that, if extra accuracy is necessary, is almost immediately ready for scraping. Now let me show you some of those tools in real steel. My hope is that these wooden models will have shown you some of the geometries in better detail than you might be able to see with the steel tools. So here's a standard roughing tool in steel. As you can see, and as we discussed before, it has front rake, it has back rake, and this particular tool has a little bit of side rake so that it's made for traveling this way across the work. And it has a blunt tip. Now, older shaper tools, when they were forged, might come in a piece of high-speed steel with an angle built into it. Some of these actually have some rake built into the back as well. This is a general purpose cutting tool. It can be used for cutting across the top or for cutting down the side of the workpiece. These tools are unlikely to be found on the market today, but you may, if you're lucky, inherit some with your shaper. Here's an actual shaper parting tool. This parting tool, as you can see, this parting tool has a small chip breaker type feature ground in the front to provide the rake, the positive rake necessary to make the cut. It has front clearance and it has side clearance on both sides, and so it's ready to cut. This is what might be termed a universal tool holder for a shaper. This tool holds a smaller cutting bit, in this case about a 3/8 inch square, and the cutting bit may then be rotated to different angles while the shank is held vertically in the shaper. These are extremely handy for cutting fine detail as well as for cutting one-off type applications where you may not want to spend a great deal of time grinding, say, a 1 inch by 1 inch bit for a shaper of this size to a particular angle. The final tool, and I'm just going to touch on this because we're going to cover it in depth later, is an internal cutting tool. And this tool is made such that it's held in the shaper and you have a shank with a smaller cutting tool held in the bit. Now, this can be used for key seating, say to cut a keyway inside a gear, as well as for a number of internal shaping operations. Now, in my opinion, internal shaping operations are one of those things that makes a shaper extra special. Cutting a square hole is not something that's possible on a milling machine, but cutting a square hole is most certainly possible on a shaper, and we'll demonstrate that in a later video. These internal cutting tools are extremely important, and they're one of the few things that has not been supplanted about the shaper with modern tools. Modern tools cutting a square hole can only be done by broaching with expensive broaches, or EDM, which is outside the scope of most home shops and expensive and slow even in modern manufacturing shops. It's been said that you can make anything with a shaper except money. That's not entirely true. You can make money with a shaper as well if the product or process that you're using requires the shaper's special features. We'll see you next time. Thanks much. Bye.